Molarity is quantitative measure of concentration. Molarity is the number of moles of solute dissolves in 1 liter of solution. Formula for molarity is molarity equals moles of solute divided by liter of solution. Okay. You need to remember that this volume is the volume of solution, not the volume of solvent. So volume of solution in liters. And from this formula, the unit of molarity is moles per liter. We write moles per liter as M. In this molarity formula, we have three variables: molarity, moles, and volume. If two of the variables are given, we can find the third variable. For instance, if we have moles and volume given, we can find molarity of the solution. And if molarity and volume are given, we can find moles for that solute. And if moles and molarity is given, we can find the volume. And that will be done by equation rearrangement. So if we rearrange this equation for mole, remember that for equation rearrangement, we use this X. And rearranging the equation for moles means we want this moles to be at the numerator and just by itself. So it is already at the numerator, means we just need to get rid of this volume. And if we want to move this volume, it will go at the top on the other side of the equation. So you will get m times v equals, okay. Now, if you have to rearrange this equation for volume, for instance, it means that you have to have this volume at the numerator and just by itself. So if we are moving it at the numerator, it can go on the other side of the equation, but we want this volume to be just by itself, so we have to move this molarity on the other side of the equation and it will come in the numerator because it will be cancelled from here. So your formula will be volume equals mole over molarity. So from this molarity formula, we actually have three formulas. We can find moles from this formula, we can find molarity from this formula, and we can find volume depending on what we need to find. Let's do this practice. What we are doing here is we are calculating molarity of a solution. So what is the molarity when 0.75 moles is dissolved in 2.5 liter of solution? All molarity problems will start with this same formula and then we will rearrange them as needed. So here is our formula. Moles are given and volume is given in liter, which is the unit we need. So we don't have to do any unit conversion. We can simply plug in these numbers in the formula. And molarity of this solution is 0.30 molar. 2 sig fig is what we need in our answer. Okay, here is another example. Again, we are calculating the molarity of the solution, but for this problem, instead of giving us moles, we have grams given. So suppose you had 58.44 grams of sodium chloride and you dissolved it in exactly 2 liters of solution. What would be the molarity of the solution? All molarity problems will start with this formula: moles over volume of solution in liter. Volume is given 2.00 liter, but moles are not given. Instead, grams are given. So we will convert these grams to moles. So let's do this scratch work on the side. Remember, grams to mole conversion is with the help of molar mass conversion factor. So we will be using that molar mass conversion factor here. And that is that 1 mole of sodium chloride. And the molar mass, if you determine with the help of a periodic table, you will be adding the mass of sodium and chlorine. So you will get 58.44 gram is the molar mass of sodium chloride. And when you cancel these and you simplify this as well, you will get 1 mole of NaCl, right? So we have moles as 1 mole. We need proper number of sig fig. It will be 4 sig figs. Okay, volume we have 2.00 liter. So our answer is 0.500 m or moles per liter. 3 sig figs here, 4 sig figs here. So we have 3 sig fig as a least number in our answer. Okay, so this is the molarity of the solution. This is the exact same problem as we did on the last slide. So how about you guys do it at your own and then play the video to check the answer. So calculate the molarity of 25.0 grams of KBr dissolved in 750 mils of solution. So again, for the molarity, because you are going to find molarity, the formula will be M equals moles over volume in liter. So volume is given here, and we are going to convert this volume to liter. So let's do the unit conversion here. So 25.0 grams of KBr. If you add masses of potassium and bromine from periodic table, you will find the molar mass of KBr. So 1 mole of KBr, potassium bromide, is 119.00 grams. So you have zero point 0.2. We have 3 sig figs here, 5 sig figs here. So your answer with 3 sig fig is 0.210 moles of KBr. The second unit conversion that we have to do is we have to convert 750 mil to liter. So let's do this here. Okay, we have both moles and liter volume. Let's just plug in these numbers in the formula. Okay, so molarity of this solution is 0.280. We have 3 sig figs here, we have 4 sig figs here. Unit will be moles per liter or simply M. I hope you guys have the same answer. Let's do another example. And for this example as well, pause the video, do this problem at your own, and then play the video to check the answer. So for this problem, 80 grams of glucose, and this time the molar mass of glucose is given. So 80 gram of glucose is dissolved in enough water to make 1 liter of solution. What is the molarity? So the formula for molarity is moles over volume. Grams are given, so we have to convert those grams to moles. So answer is 0.444. There are many fours in my calculator, but you can see that we have 3 sig figs here, 3 sig figs here. So your answer with 3 sig fig will be 0.444 moles of glucose. Now we can plug in these numbers in the formula. So moles are 0.444. Volume is 1 liter. Okay, so molarity is going to be 0.444 m. We have 3 sig figs at the top and 3 sig fig at the bottom, so your answer will have 3 sig figs as well. Our next topic is preparing a solution from solute and solvent. To prepare a solution from solute and solvent, you must do following 3 steps. Step number 1 is determine the mass of the solute needed. So remember, the formula for molarity is M equals mole over volume, right? So in this formula, we have moles, and you can find moles from this formula. But when you are preparing a solution, we cannot weigh moles. So when we have moles, you have to convert those moles to mass. Okay, so that will be one of the steps that you have to do. First, determine number of moles needed for the solution and then convert those moles to the mass. So we calculate the mass from the number of moles of solute needed. Next, you will completely dissolve that amount of solute in small volume of solvent, and then add enough water to bring the total volume of the solution up to the desired volume. These two steps are needed because when we make a molar solution, we make in volumetric flasks, and the neck area of the volumetric flasks is very narrow. If you skip step number 2 and you just add the solute in the container and then add the volume to bring the volume up to the mark, there will be no room for mixing the solute in the solution. So you really have to do this step number 2, which is that add small amount of solvent and dissolve the solute, and then add enough water to bring the volume to the mark. Now let's see this example. Explain how would you prepare 2.5 liter of a 0.350 molar solution of glucose. So remember, if you are going to prepare a solution, you need to know how many grams of solute you need and what will be the volume of the solution. So volume of the solution is given, but how many grams of solute you need? So for that, you need to first find moles with the help of these two variables, and then you will convert those moles to the gram. So let's do it. So let's first find the number of moles. We will start with our molarity formula. We need to find moles. So we will rearrange this equation for mole, and after rearrangement, your equation will be this, right? Now molarity is 0.350. Now I will break this M into moles per liter, and the volume is 2.50 liter. So the liter is cancelled and you will get moles in your answer. So you have 0.875 moles of glucose. Now, how will you prepare this solution? You have to convert these moles of glucose to grams of glucose. And whenever we do the conversion between moles to gram or grams to mole, we always use molar mass conversion factor. So molar mass of glucose we had in the previous example, and that is 1 mole of glucose is 180.0 grams of glucose. So this 180 gram is basically 6 carbon plus 12 hydrogen and 6 oxygen. So grams of glucose is cancelled here. So we have 3 sig figs here and we have 4 sig figs here. So we are going to round this to 3 sig fig, and it will be 158 grams of glucose. So in order to prepare a solution, what we will do, transfer. Okay, so that is how we prepare a 2.5 liter of a 0.35 molar solution of glucose. Okay, here we have another example. So how about you guys pause this video, solve the problem at your own, and then check your answer. So in this example, we have to explain how would you prepare 500 ml of 1.20 molar solution of potassium nitrate. So remember that in order to prepare a solution, you need to know grams of potassium nitrate to make the solution and the volume in liter, right? So to get the grams of potassium nitrate, we need moles of potassium nitrate. We have molarity and volume given. With these two variables, we will find moles. So we will start with the molarity formula. We have to find moles. So rearrange this for moles. We need volume, and we did a lot of practice how to convert milliliter volume to liters. You will be converting the milliliter volume to liter, and it will be 0.5000 liter. Okay, so we have moles of potassium nitrate. Now, next step is we are going to convert these moles of potassium nitrate to grams of potassium nitrate. To find molar mass of potassium nitrate, you will be adding the mass of potassium, nitrogen, and 3 oxygens, and you will get 101.10 grams of potassium nitrate in 1 moles. Okay, we have 3 sig figs here, 5 sig figs here. You're going to round it to 3 sig fig, and your answer will be 60.7 grams of potassium nitrate. And after that, your answer will be all those 3 steps that we did in the previous slide, that you will be dissolving this 60.7 gram of potassium nitrate in 500 ml volumetric flask. Then you will dissolve this amount of solute in small amount of solvent. Once it is completely dissolved, then you will be adding enough water to make the volume up to the 500 ml marking. So our next topic is preparing a solution from more concentrated stock solution. Remember, we learned the topic diluted and concentrated solution, and those terms diluted and concentrated are in contrast with each other. The solution with less amount of solute is called diluted solution, and the solution with more solute is called concentrated solution. If you have to prepare a solution from a more concentrated stock solution, we will be using the relationship M1V1 equals M2V2, where this one set of molarity and volume can be used for the diluted solution, and the other set will be for the concentrated solution. And you can switch these. You can say that M1V1 is for the concentrated and M2V2 is for the diluted, as long as you are keeping these paired together, which means that the molarity of the concentrated is with the volume of the concentrated, and molarity of the dilute is with the volume of the diluted. So you have to keep those together, otherwise you can switch these labels. So let's learn this topic with examples. So the first example we have is how many milliliter of 18 molar sulfuric acid are needed to prepare 500 ml of 2 molar sulfuric acid, and how would you prepare this solution? So first of all, you need to identify the type of the problem. What you are going to do is you are preparing a solution. You were preparing a solution in the previous topic as well, but in that topic you were preparing a solution from solute and solvent, right? And in this one, you are preparing a solution from more concentrated stock solution. So how will you know that in this problem you are preparing a solution with more concentrated stock solution? You will look at the information given and you will make the table of the information. So if you see that you have to find how many mils of 18 molar. So these two are together, the volume and molarity, they are together, right? Up to you, you can make them M1 V1 or you can make them M2 V2, but just keep them together. So for instance, what I will do, the first variable that I'm giving, I'll just say that this is my V1. And we have to find V1, how many mils of 18 molar. So this is my M1, and this is actually sulfuric acid, right? So how many mils of 18 molar sulfuric acid are needed to prepare 500 ml, that is my second volume, of 2 molar solution, that is my second molarity. And by looking at these molarity, I can clearly see that this M1 is the stock solution, the high concentration. And I have to prepare a diluted solution that have the molarity 2 molar. So this, looking at these information that is given, I have to identify the type of the problem. And once I know that I'm making a solution from more concentrated to a diluted, I can just use this formula M1V1 equals M2V2. Now I have to find V1, so I will simply rearrange this formula for V1, and it will be M2V2 over M1. if we are making a solution from more concentrated to a diluted solution, you do not really need to convert this milliliter volume to liter. So let's plug in the numbers and you will see that we don't really need to convert it. So we have molarity given for M2 is 2.00, V2 is 500, M1 is 18 molar. So here, if you look at the units, you can see that this M is cancelled by this M. This M have a unit moles per liter. If you have only one molarity and a volume, you really need to make sure that the unit for volume matches the unit for volume that we have in this M, right? But in this case, these two are being cancelled by each other. So this ml is left as is. So it doesn't really matter if you convert it to liter or you can use it as is. So I'm using it as is. Okay. So here I have 3 sig figs, 4 sig figs, and 2 sig fig. My answer is going to be 2 sig figs, and it will be 56 mils. So what I need is I need transfer 56 mils of 18 molar sulfuric acid to a 500 ml volumetric flask and add water to make the volume up to the mark. So here is another problem, and it is exactly same as we did in the last slide. So how about you guys do it at your own and then play the video to check the answer. So in this example, you have to explain how would you prepare 500 ml of zero point 0.1 molar solution of glucose from the stock solution that is 0.25 molar. So there are many keywords. It really says that you have a stock solution. So this is the problem where you can use M1V1 equals M2V2. And the first set I will give that this is my V1, this is my M1, and this is my M2. So definitely I have to find V2, right? So let's make the list here. Okay, we have to find V2. So we will rearrange this equation for that. And now we will plug in all these numbers in the formula. You have to be careful, don't mix up the molarities. So M1 is 0.100, volume is 500. So you have 200 mils, right? We have 3 sig figs here, 4 sig figs here, and 3 sig figs here. So if you round it, you will get 2.00 times 10 to the 2 milliliter. It is pretty much 200 mil. So you will take 200 mil of the stock solution, transfer it to the 500 mil flask, then add the water up to the 500 mil mark. Okay, now our next topic is percent composition. So in addition to molarity, we can specify the extent of amount of solute in a given amount of solution by 3 other units, and all those 3 units involve percent. The first unit is percent composition by mass. You need to remember these formulas. The formula is grams of solute divided by grams of solution. So this part sometimes become tricky if the problem is giving you the mass of solute and solvent separately and you are putting those numbers in the formula. You have to be really careful that you need the grams of solution. So you may have to add the grams of solute and solvent to get the grams of solution. So percent composition by mass is grams of solute divided by grams of solution times 100%. Percent composition by volume is volume of solute divided by volume of solution times 100%. And percent composition by mass over volume is grams of solute divided by volume of solution times 100%. So let's do some examples for this topic. So the first example is calculate the percent by mass of a solution that is prepared by mixing 35 grams of ethanol and 150 grams of. Our formula for percent composition by mass is grams of solute divided by grams of solution times 100%. Okay, so solute is these grams of ethanol, the small quantity is the solute, so 35.0 grams. For solution, 35 grams of ethanol is solute and 150 gram of water is solvent. To find solution, you need to add solute plus solvent. So you will be adding these two numbers to get the grams of solution. And you have 18.9% by mass. Our next topic is reactions in solution. We did the stoichiometry, and in that chapter, we saw reaction stoichiometry with the limiting reactant problems. We also saw the reaction stoichiometry in gas chapter, and now we are revisiting this in the solutions chapter because we have reactions in gas phase, we have reactions in solution phase, we have reactions in solid phase. So let's see reaction stoichiometry in solutions. Okay, so in this problem, you have to find how many grams of aluminum sulfate will be produced from reaction of 350 ml of 0.115 molar sulfuric acid and an excess of aluminum. The other product of the reaction is hydrogen gas. For all reaction stoichiometry problems, we start with the balanced equation. So let's write down the equation for this. This aluminum sulfate is the product of the reaction, so I will write it down on the right side. Reactants are sulfuric acid and aluminum, and the other product of the reaction is hydrogen gas. Now we will see if this equation is balanced or not. We have two hydrogens here, two hydrogens on the other side of the equation, so hydrogen is balanced. For sulfate, we have one sulfate here. I will not break sulfate into sulfur and oxygen. It is a polyatomic ion. I will keep it together. It will be easy to balance that way. So we have one sulfate here, but three sulfates here. So to balance this, I will write 3 here. By writing 3, this sulfate is balanced, but this hydrogen is 6 hydrogens now. So I have to make 6 hydrogen on this side of the equation as well. And for aluminum, I will write down 2 here. So with all this, this equation is balanced. Now, the next thing we have to do is we will write down the information that is given for sulfuric acid. So volume for sulfuric acid is given and molarity is given as well. With these two things, we can find moles of sulfuric acid. I will break down this M into moles over volume. We need to convert milliliter volume to liter. 3 sig fig, so I'm writing just 3 sig fig in my answer, and the unit is moles. So we have this much moles. We will convert these moles to moles of aluminum sulfate, and then from moles of aluminum sulfate, we will convert it to grams of aluminum sulfate. And this mole to mole conversion will come from the mole ratio from this balanced equation. So let's do this conversion here. And then from moles to gram, we need molar mass of aluminum sulfate. We have 3 sig figs here, 5 sig figs here. This is exact number. So you are going to give your answer with 3 sig figs. Your answer will be 4.58 grams of aluminum sulfate. Our next topic is titration. Titration is the reaction between an acid and a base to form salt and water. Salt is a common name that we use for ionic compounds or compounds that dissociate into their ions. The other name for the titration is the neutralization reaction, because in this reaction, the acid and base, they neutralize each other's property and make salt and water. This method can also be used to determine the concentration of an acid. Here in this image, I have the demonstration of titration. This glass tube is called burette. So we have base filled in the burette, and the molarity of this base is 0.100 molar. We have acid. We do not know the concentration of this acid. It is unknown, but we are taking exactly 50 mils of this acid. So we know the volume of the acid. We know molarity of the base. What we want to find is we want to find what is the molarity of the acid. These drops that we are adding to this acid solution are called indicator. This indicator stays clear in the acidic solution, but when we add base to the solution, and remember what happened when we add a base to the acidic solution. In acidic solution, we have hydronium ion, right? All the acidic properties are because of hydronium. In the base, when we are adding base, means we are adding hydroxide. All basic solutions have hydroxide, and when these two ions react, they simply convert into water, right? So this is the reaction taking place as we are adding this base to the acid solution. But when all of the hydronium ion from this flask are completely reacted, at that time, when we have one additional drop of the base coming to this solution, this indicator will turn pink or will change the color. So this indicator turned pink in the basic solution, and that is the indication that all the hydronium is completely converted into the water and all the acid is gone and reaction is complete. So at that point, when this solution turned pink, we will stop adding base to this solution, right? And at that point, if we look at the reading, so the reading is 22.50 mil, and this is actually the volume of the base. So now from this experiment, we have molarity of the base, we have volume of the base, we have volume of the acid. With all these things, we can actually find what is the molarity of the acid. So here are the steps to calculate the molarity of acid. First step is you need to determine the moles of base. And how to determine the moles of base? You can see that we have molarity of the base and we have the volume of the base. To find moles, we will be multiplying these two numbers and we can find moles of base. Right? These two numbers will give you the moles of base. So once you have moles of base, you will convert the moles of base into the moles of acid. So this is actually telling us that we need the mole ratio from the balanced equation. So remember this point that for all titration problems or neutralization problems, start with a balanced equation. Only with the help of balanced equation you will able to convert moles of base to the moles of acid. Once you have the moles of acid, you can find molarity because you already have the volume of acid, right? So you have the volume of acid, you determine the moles of acid. With those two, just find the molarity of the acid. So let's do one practice for this. So here is our practice problem. We have 50 ml of sulfuric acid. So this is my volume, and concentration for sulfuric acid is unknown. This is treated with zero point 0.1 molar base. This is another molarity, and here we have another volume. Now I want to caution you guys here that sometimes students mix this problem with the M1V1 equals M2V2 problem, which is preparing a solution from the stock solution. The reason they can mix it with that type of problem is because in that problem as well, you have two volumes and two molarities. But there is a difference in this problem and that difference is when you are preparing a diluted solution from a stock solution, you have only one type of reagent given in the problem. But here you have two reagents, molarity and volume of sulfuric acid and the molarity and volume of sodium hydroxide. So two different species are involved in this problem. And when you have different species involved in the problem, it is the titration problem. You will see that there is acid and there is base. There are some keywords like neutralize the acid. So all these are the indication that this is a titration problem, and you have to start with the balanced equation. Okay, so let's write down the equation between sulfuric acid and sodium hydroxide. We have three hydrogens here, two hydrogens here. So we will balance hydrogens later. We have two sodiums here. We have one sodium here and two sodium here. To balance this, we have to write two here. Sulfate looks balanced. For hydrogen, now we have four hydrogens, two from here and two from here, and two oxygens. So I think if we just write down two here, this will balance this whole equation, giving us a mole ratio between sulfuric acid and sodium hydroxide 1 to 2. Now for sulfuric acid, we have volume given as 50 ml. Its molarity is what we need to find. For sodium hydroxide, volume is 32.30 ml and molarity is 0.100. So you have to find moles from here, right? Because that is the first step. So to find moles, it will be m times v. So we have this much moles of sodium hydroxide. Remember, our next step is to convert the moles of hydroxide to moles of sulfuric acid. So let's do that step. We need mole ratio from balanced equation. So 2 moles of sodium hydroxide are needed for every 1 mole of sulfuric acid. Okay, so these are the moles of sulfuric acid. Next step, we have to find molarity, and molarity of sulfuric acid is moles over volume in liter. So this will be the answer. Okay, here we have another example. How about you guys do this at yourself and then play the video to check the answer. Okay, in this problem as well, when I looked at the information given, we have one volume given, one molarity given here, and one molarity given here, and I have to find another volume here. So we have two sets of molarity and volumes. When I looked at the species given, we have two different species. We have sulfuric acid and magnesium hydroxide. So this is not a typical M1V1 or preparing a solution from the stock solution problem. It is a neutralization or titration problem. And for all neutralization or titration problem, I have to start with the balanced equation. So I will write down the balanced equation first. Okay, we have one magnesium, one magnesium, one sulfate, one sulfate. For hydrogen, we have two hydrogen here and two here, so total of four hydrogens and two oxygen in the reactant. So I have to write down two here to make it balanced. And look at the mole ratio between sulfuric acid and magnesium hydroxide. It is 1 to 1 mole ratio, right? So after writing the balanced equation for a neutralization reaction, if you end up getting a 1-to-1 ratio, it is okay if you want to use M1V1 equals M2V2 formula to solve this problem. You can still do all these steps, which is like find the moles from these two, convert those moles to the moles of magnesium hydroxide, but since the mole ratio is 1-to-1, you will get the same moles of magnesium hydroxide, and then from there you can find the volume. So you can do it that way, but this is also acceptable because the mole ratio is 1-to-1. If the mole ratio is anything else, like we had in the previous problem, here the mole ratio was 1 to 2, right, from here. So for this problem, you cannot use M1V1 equals M2V2, but here you can use it. So if you see that you have to find volume of magnesium hydroxide, right, and you can rearrange this and you can use this formula to get the volume of magnesium hydroxide. So it will be, okay, so your answer will be 10 mils of magnesium hydroxide, and you know why it is. Their molarities are same, zero point 0.5 molar, zero point 0.5 molar. Their mole ratio is same, 1-to-1. So the 10 mils of sulfuric acid will need 10 mils of magnesium hydroxide to completely neutralize that solution. I hope you guys have the same answer.